Hello, this video is for section 3.5 of the textbook, Conditional Proof. Section 3.6 is some techniques for approaching proofs. I'm not going to do a video for that because anyone can just, I think reading that is fine. I don't know if anything is gained by me doing a video for it. I might in the future if it seems like it'll help, but for now I'm just going to do section 3.5. The topic of 3.5 is conditional proof. And this is the first of two proof strategies, what I'm going to call proof strategies. The other one is indirect proof, and we'll do that in chapter 4. But the current topic is conditional proof. Now, I'm going to do a little bit of a tangent here to sort of give you the basic idea of what's happening in conditional proof, a sort of metaphor. So think for a minute about poisonous liquids, right? And in particular, like a lethal liquid. What does that mean? What does it mean for a liquid to be lethal? Okay, well, it's meaning you could capture in terms of a conditional, right? If someone drinks it, then that person will be killed, right? Or if someone were to drink it, then that person would be killed. Okay. Now, importantly, for that conditional, for a lethal liquid, the antecedent and consequent might both be false, right? And the liquid's still lethal, right? Maybe nobody's ever drunk the liquid, so the antecedent's false. As a result, that liquid has never killed anyone, so the consequent is false, right? It could still be the case that the liquid is still lethal. And it would be lethal because if someone were to drink the liquid, then that person would be killed, because the conditional can still be true even if the antecedent and consequent are actually false. So suppose you're in a chemistry class, you discover a new liquid, and you're curious. You wonder if this liquid is lethal. What you're wondering then is you're wondering if a certain conditional is true. And let's just call this conditional if D then K, where D stands for if someone drinks the liquid, K is then the liquid will kill that person, something like that. So you want to know if this conditional is true. When you're wondering if the liquid is lethal, this conditional is what you're trying to find out, right? Is that conditional true or not? Well, how can you tell if that conditional is true? Well, here's one way you could do it. You could make the antecedent true and see if the consequent becomes true as a result. So you might get your friend to drink the liquid, which would make the antecedent true, right? Oh, now someone has drunk the liquid. And then see if, once you make the antecedent true, the consequent becomes true, right? Do they die? So you get them to drink the liquid, and then you see what happens. And if they die, then you know that the liquid is lethal. You know that that conditional is true. Okay, so the upside of that process is that you can verify that the conditional if D then K is true, right? The downside is you have to kill your friend, okay, which is a significant downside. Now, ideally, what you would like to be able to do is to have your friend drink the liquid to see if they die, but have that whole process not really count somehow, okay? Like cross your fingers behind your back, or you get, after your friend dies, you go back in time and you convince yourself not to make your friend drink the liquid. You say, okay, look, I'm from the future. You had your friend drink the liquid, they died, so now we know that the liquid is lethal, so you don't actually make your friend drink the liquid. Okay? Something like that. Some way that you can make that whole process not actually count. You could still get the knowledge that the conditional is true without having to actually kill your friend. Now, you can't do that in real life, right? Unless you built a time machine or something. Okay, but you can do it in a proof. And in fact, that's kind of what is behind the idea of conditional proof. At a certain point, you want to establish that some conditional, misspelled here, if phi then psi is true. So there's a conditional you're trying to establish. So what do? Well, you're going to make the antecedent phi true, and then see if the consequent, psi, is true as a result of that. Okay? However, in the proof, there's a way to do it where you don't really make the antecedent true. You're just pretending that the antecedent is true. Then once you verify that the conditional would be true if the antecedent were true, then you sort of unmake it true. You sort of just say, oh, just kidding. The antecedent really isn't true, but I did want to just establish this conditional. Okay, so that's kind of the metaphor of how conditional proof works. Let's go through in a little more detail without the metaphor. The basic idea is that at some point in the proof, you want to derive a conditional, if phi then psi. And you can't figure out how to do it just using the rules. I mean, if you could just use the rules to do it, that would be great. You wouldn't need to use conditional proof. But at some point, you want to derive that conditional on a line, but it's not obvious how to do it. Well, here's one way to do it. You assume phi and derive psi. And assuming phi, that's like pretending that phi is true. And then deriving psi, that's your way of like seeing if, once you pretend phi is true, does psi really follow from that? So, in particular, what you do is you just add a line that consists of phi. Now this is a line, it wasn't a premise, and it wasn't something you derived from a premise. The justification for this line is just an assumption for conditional proof. This is where you are just pretending that something is true in the proof. Okay, think of it that way. This is you making your friend drink the liquid. Okay, but you know it's just going to be pretend. You're going to be able to undo it later. Okay, so you've assumed phi. And then you proceed using the rules. But now your goal is to derive psi. You want to see if psi is true now. Now that you've pretended phi is true, is psi also going to be true? Now remember, at this point, we don't know if phi really is true or not. We're just pretending, okay? And we don't know if psi is true, pretending you assume you actually did manage to derive psi, right? We don't know if it really is true because we got to psi once we only just pretended phi was true, right? But what you do know is that conditional is true, right? You do know that if phi, then psi, right? If you knew you could you could sort of make your friend drink the liquid just for pretend, you make him drink it, he dies, then you go, oh, just pretending, but now at least I know that that conditional is true, okay? So this fact of this, what we're going to call this subproof, this is the part of the proof that's just kind of where you're pretending that phi is true, that you managed to derive psi. You still haven't shown that phi really is true, and you still haven't shown that psi really is true, but what you have shown is that the conditional is true. If phi, then psi. Okay, so once you do that, then you can validly write your conditional on a line in the proof that's real. Now that conditional is for real. Okay, it's not pretend. The conditional is real. So let's see an example. Here's a proof, and the conclusion is if G, then K. And I think that with the rules that we have so far, we really can't do this proof. You can't derive that conditional from those premises using the rules that we have so far. But we can use conditional proof. Right now, I see that what I want, there's a conditional I want to get. I can use conditional proof to do that. So I'm going to walk you through this process. So step one, I want to get clear on exactly what conditional it is that I'm trying to establish. What am I trying to derive? And it's if G, then K. In this case, it happens to be the conclusion. And the reason I want it is because if I can derive it, then my proof's over. But that's not always the case. Sometimes I might want a conditional just because it's not the conclusion, but I know that if I had that conditional, I would be able to get the conclusion somehow. That's a piece that I need as part of my process. But in this case, it's the conclusion. So I'm clear on the conditional I want. Next step, assume the antecedent of that conditional. I'm going to pretend that the antecedent is true. We're going to call it assuming the antecedent is true. So what is that antecedent? It's G. So I'm going to assume G. And how I'm going to do that is I'm going to start what's called a subproof. This is kind of like the little pretend part of your proof here. I'm going to draw an arrow, and this is just like an arrow pointing at the thing that I'm assuming, that I'm just pretending is true temporarily. I'm going to justify it with ACP, that's assumption for conditional proof. And the rest of my lines are going to be indented here. So it's going to be a way for me to graphically represent the fact that everything that I derive from here on out is in part based on this pretend statement here that didn't really come from the premises. I'm just temporarily pretending it's true. But at this point now, I just start deriving lines as usual. I go back to using the rules, but now I have this other line that I can use. My goal now is to derive the consequent of the conditional I want. Okay, and the conditional I want is if G then K, so I'm going to try to derive K, right? This is like, once you make your friend drink the liquid, the thing you're waiting to see, the thing you want to know if happens is, does he die, right? The consequent, that's the thing that you need to assess after you make your friend drink the liquid, right? The consequent. So now we're going to try to derive K. So let's do that. I can do modus ponens on 3 and 1 to get T. Then I can go T or S by using DI on line 4. Then I can get K from that by modus ponens on 2 and 5. And now I've got K, right? I've shown that if I pretend G is true, if I assume G, K will follow from that. Okay, so this is, I made my friend drink the liquid, and sure enough, he died. Okay, so mission accomplished. I've derived the consequent. So now I'm going to end my subproof. This is the part you can't do in the real world, right? This is where I'm going to just say, oh, just pretending. All of that stuff I just did was for pretend. It doesn't really count. I'm going to draw a line. This is called, it's closing the subproof. Draw a line from the conclusion, or the consequent that I was trying to derive, all the way up to my initial assumption. And that's just going to graphically sort of mark off this part of the proof, what we'll call a subproof. Okay. Then on the next line, when I've completed the conditional proof subproof, the next line, the only thing you're allowed to write is a conditional whose antecedent is the first line of the your conditional proof, your ACP, and whose consequent is the last line. Okay, so it's going to be conditional if G then K, which is what I wanted, right? I wanted if G then K, which is why I made this the first line and why I ended it here, so that that would be the last line. Okay, and then the justification is just going to be the whole subproof. So it'll be 3 through 6 conditional proof. Okay, let's do another example. This is another conditional. Again, this is an example where I'm going to use conditional proof specifically to derive the conclusion, but we'll see examples where you use conditional proof, but what you're trying to derive isn't the conclusion. The conditional is a piece you need for other things to get to the conclusion. But this is the conclusion. The conditional I want is if X then Y. So I'm going to assume X on the next line. I'm going to indent, I'm going to draw a little arrow to sort of start my subproof. My justification is ACP. Now my goal is what? To derive the consequent Y of the conditional that I want. How can I get Y? Well, it's not too hard. Okay, I have a conditional, this is the antecedent, I can get not Z by modus ponens on 3 and 1. Now that I have not Z, I can do disjunctive syllogism on 2 and 4, right? I have a disjunction, I have the negation of the first disjunct, So I can derive the second disjunct, which is y. So bam, your friend died. Okay, that's the consequent you were looking for, is not y. So now you know that that conditional, if x then y, is true. So we're going to close the subproof, draw the line from y back up to x. And then remember, on the next line, the only thing you can write is a conditional whose antecedent is the ACP and whose consequent is the last line of the subproof. All right, let's do another example. Now notice with this one, the conclusion isn't a conditional. Okay? So does that mean you can't use conditional proof? No, you can still use conditional proof because maybe you use it to derive a conditional that you then use for some other purpose. Even though it's not the conclusion, it's still useful for you. Well, notice this might be the case here, right? We have this conditional, if k then L, then M. So I know that if I could get this conditional on a line by itself, right, suppose I had line 6 was just if k then L, then I could do modus ponens on 1 and 6 to get M, right? So I'm thinking, great, if I can get this conditional, then I'm only one step away from finishing. So one way to do it would be to derive this conditional. We can't do it now with the rules we have. Once we get to chapter 4, we'll be able to do that with the rules that we'll get. But for now, we can still do it. We can use conditional proof. I'm going to assume k and try to derive L. So there's k. I can do modus ponens on 4 and 2 to get S or L. Then look, with 3 and 5, 3 is the negation of the first disjunct in 5. So I can derive the second disjunct by disjunctive syllogism. So 3, 5, ds. Now I should close my subproof because this is the consequent I want my conditional to have. The conditional I want is if k then L. So now is when I'm going to close this and say, okay, that was my subproof. If k then L, and that's 4 through 6 conditional proof, but I'm not done, right? This isn't the conclusion of the argument, right? This is just something I know will help me get to the conclusion. And in fact, it's going to help me pretty quickly because this is the antecedent of this conditional. So by modus ponens, I can get M. All right. Now that we've seen a couple examples of conditional proof sort of in action, what I want to do is to go through some rules for using conditional proof, okay? Just to make sure that everyone's doing them correctly because there's some mistakes that could be made. The first thing you do, once you decide you want to use conditional proof and you're clear on what the antecedent, what is the conditional you want, you know its antecedent, you know its consequent. You start your subproof by indenting, right? You draw a little arrow and you indent, and you designate the first line. Your justification is ACP, assumption for conditional proof. Okay? A conditional proof can end any time you want it to end. And I'm underlining this because the other proof strategy we're going to get in chapter 4, indirect proof, this isn't true. In indirect proof, you have to derive something very specific before you can end that proof. If you try to end it any other time, then you've done indirect proof incorrectly. With conditional proof, you can end it any time you want. Okay? So for example, let's go back to this proof we just did, right? Where I knew I wanted if k then L, I assumed k, I derived L, that was my subproof, and then I got M by modus ponens. Okay. Now I ended it on line 6. I could have, if I wanted to, let's go back, I could have ended it at line 5. That wouldn't be wrong. Okay, so if I did this, I wouldn't lose any points so far if someone was grading my proof. I mean, my proof's not done yet, but just doing this isn't wrong. This wouldn't be any points off. Why didn't I end it here? Well, not because doing so would have been wrong, but because doing so would have given me something that wouldn't have helped me, right? If I ended it here, then the conditional that I would have derived would have been if k, then S or L, right? the consequent has to be my last line. But this doesn't help me at all. In fact, I've already got this up here on line 2, right? So even though it's not wrong to end it at line 5, because I can end it at any time, I could end it at line 5 I want. If I end it there, I get something that's useless, right? Something that doesn't help me. So that's why I didn't do that. Okay, and that's why instead I ended it at L, because if I ended at L, line 6, then the thing I end up with is something that helps me. Okay, so the point is that conditional proof can end any time you want, but it's only advisable to end it once you've derived the consequent of the conditional you want to end up with. Okay, next rule. Once you've done that, once you've ended your conditional proof, you mark it off, you close the subproof by just drawing a line from the bottom of the last line all the way up to the arrow. Okay, and that just makes a nice graphical representation of anyone looking at your proof. They know that's a subproof. Okay, sometimes that's also called discharging the assumption. The next line after you've closed your conditional proof subproof, the next line can only be one thing. Okay, it has to be conditional, whose antecedent is your ACP and whose consequent is the last line of your subproof. Okay, and that might sound like, oh, it's this tight restriction, but it's not a tight restriction. That's what you wanted, right? You wanted a conditional that's why you picked the ACP you did, right? It's because you wanted that to be the antecedent. And it's why you ended the proof where you did. It's because you wanted the last line to be the consequent. So you're exploiting this rule for your own benefit. Okay, next rule, number 5. All subproofs have to be closed before your proof can end. So what do I mean by that? Look at this proof. We haven't done simplification yet, I don't think, so don't worry about that. That's just a rule we're gonna, oh no, wait, we have. So here's your premises. We're trying to get A or B. Someone assumed R, then they got D and A, they simplified A off, and maybe that person thinks, oh, look, I've got A now, I can get A or B by DI on line 6, so now I'm done. And they just then turn in the quiz. Okay. No. Why is this bad? Because you started a subproof, but you didn't end it. You didn't close the subproof. Okay. So that's bad. Red X. You can't do that. Okay. Before your proof is over, before your proof is finished, you have to close all of the subproofs that you have. Okay. And 6, once you've closed a subproof, you can't anymore cite individual lines inside that proof. That's quarantined off, right? Because that was stuff that you were just pretending, essentially. You don't know if it's really true or not. It was only true based on a pretend assumption you made. Once you close that subproof, those lines all have to be quarantined. Okay, so for example, here is a legit version of this proof. Don't worry about it, but someone derived this, blah, blah, blah. They got to A or B by DI on line 8, right? But suppose they did something else. Suppose what they did is they got down to here, they closed the proof, they got if R then A, then they said, oh, I know how to finish this proof. I'll do simplification on line 5 to get A by itself, and then I can go A or B. Okay? Suppose they did that. Well, that would be bad, right? Because right here, they're citing a line that's in a subproof that's been closed. Okay? Once this is closed off, from line 7 on, no individual lines in this can be cited anymore. What do I mean when I say individual lines? Well, clearly on 7, we've cited the whole subproof. Okay, so that's fine. But you can't do this. You can't, go to the individual lines as opposed to the whole subproof, right? Which is what this person tried to do. So that's another red X. Don't do that. Okay, let's see another example. What we're trying to get is if B then D. Again, that's a conditional. We can try conditional proof. I'm going to do this in a little bit of a different way, but you'll see where I'm going. Okay, I'm going to assume B is assumption for conditional proof. Get B or D, and that's by disjunction introduction. Then I'm going to get D. How did I get D? Well, I've got B or D. I've got not B here. Okay, so that's the negation of that, so I can get D by ds. That's the consequent I was looking for. So I can close this subproof off. And the next line has to be a conditional whose antecedent is your first line, whose consequent is the last line. If B, then D. 5 through 7 conditional proof. And that's the conclusion, so I'm done. Okay, let's do another one. Okay, what we're doing here, it's interesting. For some reason, this is not a conditional proof. I'm not sure why I have this one here. We could do conditional proof with this, but the slides I have here aren't conditional proof. So we'll just do this one the old-fashioned way, okay, not using any subproofs. Should be pretty obvious to you by now how this is going to look, right? I've got R and S. I can simplify R. Once I've got R by itself, I can go R or G by DI to get this antecedent. Once I've got that, I can get not A by modus ponens, and then once I have not A, I can get W by disjunctive syllogism, and then once I have W, I can get W or X by DI again. Okay, if that was too quick, just watch. I'm going to sort of go through what I just said. But ideally, you would get to the point where you're familiar enough with the rules and you've done enough proofs that you will be able to do kind of what I just did, right, in your head. You can just sort of look and sort of think your way through all of the steps, you know, in 10 or 15 seconds. Okay, first up, I'm going to simplify R. Then I'm going to R or G by DI. Now 5, on DI on line 4. Line 5 is the antecedent of the conditional on line 1, so I can do modus ponens on 5 and 1 to get the consequent, not A. Now, 6, not A, that's the negation of one of the disjuncts on line 2, right? It's the negation of the first disjunct. So by ds, I can get the other disjunct, W, on a line by itself. And now, W, I notice, oh look, conclusion is disjunction, one of the disjuncts is W, so I can use DI again to get W or X. Okay. This one you will use conditional proof. What I'm trying to derive is actually a conjunction of two conditionals. So I'm just going to go ahead and use conditional proof twice. I'm going to use it once to get this one and once to get that one. Okay, so first I want to get if R then A. So I'm going to assume R, and now my goal is just to get A. And you should be able to see that's going to be pretty easy, right? Because I've got R, I can get D and A, and I can just simplify A off. So that's what I'm going to do. So now I've got R, I can get D and A by modus ponens on 4 and 1, simplify A. Now I'm going to close my subproof. Because remember, I wanted if R then A. This was the conclusion I was trying to get. So I'm going to close my subproof. And now the next line is a conditional. Antecedent is the first line, consequent is the last line, if R then A. But I'm not done. Okay? I also need this conditional. So I'm going to do another conditional proof subproof. This time I'm going to assume S and try to derive B. So there's S. And look, deriving B is now really fast because S is the negation of this disjunct, so I can get B by ds. Now at this point in the proof, I can't cite lines 4, 5, or 6. These are in a closed subproof. Okay, but everything else is fine. I can cite line 7 if I want. I can cite 1, 2, and 3. Those are all still available lines. The only stuff that's quarantined is 4 through 6. But I'm not using 4 through 6. I'm using 8 and 3. DS on 8 and 3. Now I'm going to close that subproof. I've got a conditional if S then B. Now I'm just going to put those two conditionals together. Keep in mind on line 11, there's a bunch of lines I can't access anymore. I can't any longer cite 8 or 9. That's a closed subproof. I can't cite 4, 5, or 6. That's a closed subproof. But I can cite 1, 2, 3. That's fine. 7 is fine, and 10 is fine. And 7 and 10 are the ones I need. Okay, because I'm going to use conjunction to put them together into that. So if R then A and if S then B, and that's by 710 conjunction. Okay, that is it for section 3.5.